Hey guys, welcome back to my channel, and I hope you guys are having a wonderful day. In today's video, I'll be going over constant acceleration. So without any more talking, let's just get started. Okay, so we're talking about constant acceleration, and acceleration itself is any change in motion. That could be an increase in speed, decrease in speed, or a change in direction. All of that applies to change in motion, so those apply to acceleration. So acceleration is basically how, another way to define it is how fast your velocity is changing, which could be your speed or your direction. Okay, so acceleration, the formula for acceleration is a delta velocity over delta time, and delta basically means a change in something. So that is your change in velocity and your change in time. So v2 minus v1 over t2 minus t1, that's basically your y and your x-axis. Time is always going to be your x-axis and velocity is going to be your y-axis. So basically it's like y2 minus y1, like you solve slope, because basically it is slope, just it's not y anymore because y is represented by velocity, but it is y, but you know what I'm saying. And the what's it called, the unit measurements for acceleration would be meter per second squared or meters per second. Acceleration can either be a positive or negative change in motion. So like I said, it could be increase in speed, decrease in speed, or just a change in direction. It doesn't matter. Any change in motion is acceleration. And so a negative change is called a deceleration. So basically just accelerating in the opposite direction. The formula is, okay, so some formulas for actual constant acceleration, because this was kind of like a review for what acceleration is, but now we're talking about constant acceleration. So the formulas are, if you're looking for a final velocity, you could take final velocity squared equals initial velocity squared plus 2 times acceleration times distance. Another way to find final velocity is equal to initial velocity plus acceleration times time. The difference between these two is one of them has time and the other one has distance. So whichever one you're given in your problem will determine which one you use, and will determine which one you use for it. So if your problem gives you acceleration, velocity, and time, then you obviously use the second one. And if it gives you distance and acceleration and velocity, you would obviously use the first one. And the thing about this one is you see the square, right? So whenever you solve for this whole side, you have to take the square root to get final velocity, because you have to get rid of the squared, and you can't do that without taking the square root or your answer is going to be wrong. And if you're looking for distance, you need velocity times time plus 1/2 times acceleration times time squared. Don't forget to do these, your answer is going to be wrong. Okay, so let's go over some practice questions I did throughout the day. So final velocity, the initial velocity plus acceleration times time. The initial velocity was 2, acceleration was -0.5, and my time was 2. When I solved for that, I ended up getting, what is 2 times 0.5? That is 1, -1. So 2 minus 1, my answer would have been 1. Let me see if I actually solved any of them. I didn't. I'm gonna just do new problems and solve for you guys and give you an example for each problem, so you guys can understand if you don't already. Okay, so the first problem says an airplane accelerates down a runway at 3.20 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. So basically they're asking us to solve for distance, and we know the formula for distance is equal to velocity, initial velocity times time plus 1/2 times acceleration times squared. So we're just going to fill in the units. So distance equals, so they didn't tell us the velocity. Yeah, they never tell us the velocity, so we're gonna assume that it was at a flat velocity, so 0. and the time is 32.8. It doesn't really matter since one of them is 0, so if you multiply it's going to be 0. I'm going to write it out just for the purpose of people who need time to understand it. Acceleration is 3.20. You can identify acceleration with the meters per second squared really easily, times time, which is 32.8 squared. Yes, I was right about the initial velocity because the question said until it finally lifts up the ground, so it is at rest. So basically this is 0, so 0 plus 1/2 times 3.2 times 32.8 squared. Hold on while I get my calculator. Okay, and I'm back. So 0.5, make sure you guys can see, times 3.2 times 32.8 squared. Your answer is 1721.34. And yes, ma'am. I don't know if I can write this out. Okay, so the next problem is an airplane flying 60 meters per second is accelerated uniformly at the rate of 0.5 meters per second squared. What is its velocity at the end of 10 seconds? So basically we know velocity, the initial velocity, we know the time, and we know the acceleration rate. So and we're looking for velocity, the final velocity, so that means we can use the second formula because they never gave us distance, so we can't use this one, so we have to use this because this is what we have and what we need. So we're gonna write final velocity equals initial velocity plus acceleration times time, and so you just plug everything in. Final velocity equals, and your initial velocity was 60 meters per second plus acceleration of 0.5 times 2. No. Your time was 10 actually. Sorry. And so remember you have to add this to this. So 0.5 times 10 is 5 plus the 60. So your final velocity is going to be 65 meters per second. And that's it for final velocity. Okay, so for distance, this is the problem for distance. It says a plane flying at 80 meters per second is uniformly accelerated at the rate of 2 meters per second squared. What is the distance it will travel during a 10-second interval after acceleration begins? So basically, we know what the initial velocity is, we know what the acceleration is, and we know what the time is. So we can find distance. So distance is initial velocity times time plus 1/2 acceleration time squared. The formula is long for no reason. But distance equals, we know that the initial velocity is 80. We know that the time is 10 seconds plus 1/2 times acceleration, which acceleration is 2, and time is 10 seconds. Don't forget you have to square that. So if I were to solve this, I would put 80 times 10, that's 800 plus 0.5 times 2 times 800, because 10 squared is 100, you get 100. And when you add that together, your distance is equal to 900 meters. And that's it. One problem for each way that you can be given that from word problems. So in conclusion, don't get thrown off by words that he put, and read it carefully. If you're confused, just look at the questions, use the units to your advantage, learn the units, and so you know which one is distance, acceleration, time, initial velocity, final velocity, so you can just know what is given to you, so you can look at your formula and know which formula to use. And if you're confused, just look at the end of the, so like I was saying, if you're still confused about finding stuff, just go to end your problem, look for what you're looking for, identify the unknown and what they're asking of you, identify what you're giving, and just plug into the equation, follow the equation, take your time, put your calculator correctly. If it's hard for you to put it all at once and you keep getting it wrong, break it down, write it out, and just find your answer. And practice makes perfect, so keep practicing until you get it. Thank you guys so much for watching to the very end. I really do appreciate it. I hope you guys found the video helpful and you learned something new. Feel free to like, comment, subscribe, and don't forget to turn on notifications so you don't miss another upload. I hope to see you guys in the next one. Bye guys.